we're going to let L be the number of markers entering the reactor. We're going to write all the answers in terms of L. So we're going to figure that out ahead of time and then answer the questions. How many large markers leave the reactor? L come in and 40% are reacted, so 60% leave the reactor. How many small markers leave the reactor? L large ones come in and 40% react, so there must be 0.4 L. How many small markers go out of the separator at the bottom? Well, all the small go out, so that's 0.4 L. How many large markers go out the overhead stream? They all go out the overhead stream, so that's 0.6 L. How many large markers come in the process feed? 0.6 L come in the recycle, and L go out, so there must be 0.4 L. What's the ratio of small out the outlet to large in the process feed? It's the same. What's the overall conversion of large to small for the process? It's 100%. Earlier we worked the process with L equal to 10. Now we've worked it for any L. We choose as a basis L equal 25. Write the flow rate of L and S on your mass balance table for this process. Check the mass balance table around each unit and press return when complete. How many small in the reactor inlet? How many small are there in the reactor outlet? How many small are in the bottom stream of the separator? Well, if there are 10 coming in and they all go out the bottom, there will be 10. How many small are there in the overhead stream of the separator? 0. How many small are there in the process inlet? That will be 0 too. How many large are in the reactor outlet? How many large are in the separator bottom stream? How many large are in the recycle stream? How many large are in the process inlet? Next, we choose a basis of 10 large fed to the process. Let T be the number of large contained in the recycle stream. How many large come out of the mixer? 10 plus T. How many large are reacted? Well, 40% react, and so that would be 4 plus 0.4 T. How many large are unreacted? That would be the rest. So that would be 6 plus 0.6. I'll go to the separator overhead. That will be 6 plus 0.6 T. This is the same number we call t. Set it equal to t and solve for t. What is t? T is equal to 6 plus 0.6t, or 0.4t equals 6. Therefore, t is equal to 15. How many L in the overhead stream? That would be 15. How many L in the process feed? That was 10. How many small in the reactor inlet? That would be 0. In the reactor outlet, we formed 10, so that will be 10. And in the separator bottom, it will be all of them, so that's 10. In the separator overhead, none of them, that would be 0. In the process inlet, there aren't any, and so that you see the numbers work out just like the equations did. To solve any recycle mass balance, we use two techniques. Either assume a flow rate into the reactor, a technique called breaking the recycle loop, or assuming a recycle flow rate. Once this choice is made, it is easy to do the mass balances. You did so by counting markers. Usually, however, we cannot make this choice. Then we solve it using an algebraic variable. Then we proceed as before, using the same ideas, unit by unit, until we have covered the loop. We then have two algebraic expressions for the same thing. We equate them and solve. Finally, we check the balances with the numbers. If you apply these same principles in other problems, you can solve them all. Good luck.